Hello everyone. I hope you all are doing amazing in your life. I welcome you all to third video of finding number of edges given the vertices and connected components. So in the previous two videos, we saw how to find maximum number of possible edges when we have vertices and components given in the question. In this video, we'll do the exact opposite. eh, we find we'll try to find or we'll see how to find minimum number of possible minimum number of possible edges given that we have number of vertices and connected components. So let's try to solve one such question. So we have an undirected graph, all right, with again 20 vertices. So 20 vertices we have, and number of connected number of connected component, number of connected components are 5. All right. And what do we need to find? What do we have to find? Number of minimum number of minimum number of possible. This we need to find. This is an undirected graph. Right. Now, I want you guys to pause for a minute and think about it. Try to connect it with the previous two problems and try to figure out if you could solve this problem with the same approach or not. Take a moment, and think about it. I hope you have thought about it. So if you remember what we were doing in question where we were supposed to find maximum number of edges, we uh, we we were trying to bring as many vertices as possible together such that it satisfies the condition given in the question, right? This is what we were doing here. What we'll do the exact opposite. We'll try to bring as less vertices as possible together, because we know this: more the number of vertices, more the edges can be drawn. Less the number of vertices, less will be edges there, right? So we'll apply this concept here. We'll try to bring as less vertices as possible together so that we could find the minimum number of possible edges, right? So we'll try to distribute these 20 vertices into 5 components, keeping in mind that we have to bring as less vertices as possible together. All right, this is the condition. Let me write that. Condition is try to bring as less vertices as possible together. So we will try to discover such a combination of uh, vertices. All right. So we have 20 vertices and we need to distribute it into 5 components. So one way is 5, 5, 5, then 3, 2. So the maximum number of vertices which one component has is 5. Can we Can we find another which is less than 5? Can we do that? Let's try. What about this one? 4, 4, 4, 4, 4. Now, can we find another combination of vertices where it is even lesser than 4? Is it possible? Think about it. Is it possible or not? I'm also thinking. I myself don't know. Hmm, I don't think. I don't think it is possible. So I guess we have figured out the the best possible number of possible combination of vertices which satisfy the given condition, right? Now what we have to do, we have to find the minimum number of edges. Let's draw one component here, because if we can draw one component and find out how many edges are there, all the other components have the same number of vertices. So 1, 2, 3, 4. We have to draw a connected component. Remember this. 1, 2, 3, 4. It is connected component. Can we draw another graph which is connected but have less number of edges than this graph? Can we do that? Yes, we can. I'll draw it here. 1, 2, 3, 4. Join this, and simply join this. See, this graph is also connected, okay, and it has only three edges. So this is the least number of edges that we can have in a connected component with 4 vertices. Since one uh, since one component with 4 vertices can have three edges, so we have 5 such components. Therefore, possible number of minimum number of edges possible in this combination of vertices would be, it's again lacking. Where is the cursor? Yeah, would be 3 into 5. You can multiply. My pen tab is again lacking. I gotta fix it. I'll look into it. So भाई काम कर ले यार. All right. So uh, in in a component which has 4 vertices, minimum number of edges possible is 3. Therefore, we have 5 such component. So 3 into 5 would be 15. So 15 is the minimum number of possible edges possible edges in this graph. All right. Now this is the manual work that you have to do. We were doing same when we were supposed to find maximum number of edges in a graph. There also we saw an formula to do our calculation fast, and that formula indeed saves a lot of our time. So for this for these type of problems as well, we have a formula that we can use, and we'll be able to solve this question as as soon as we see the question on our screen. So how many vertices we have? 20. And connected components 5. What we have to find? Minimum number of minimum number of edges, right? What do you have to just minus these two, we will get. So formula is simple, n minus. Okay, I'm not sure if I used this formula in previous video or not. I'm not sure about that. So what is n here? N is number of vertices, while k is number of connected components. All right. I hope now you'll be able to solve. You'll be able to take. You'll be able to solve these type of questions. So that's all for this video. Thank you for watching. Have a good day. Bye bye. Take care and happy learning.